Well, it's good to be here. It's good to see you all here. We've got to cover a very big topic tonight. It's going to cover an awful lot of things because the subject is actually very vast when you start thinking about the global flood, or the Noah's flood, the flood of Noah as it is known. And we're going to look at the evidence from the rocks and the fossils and try and work out what it all means to us and what can we conclude from all these various bits of evidence. Get this zapper to work. So just a quick overview of where we're going tonight, so you know more or less where we're going, where we're going to end up. We're going to actually start with what the Bible says about the flood, because that's really the crux of the matter, because if the Bible didn't mention the flood, we wouldn't have very much to talk about. And then we're going to have a quick, very rapid review of the history of geology to set the context, followed by a discussion of uniformitarianism, which is part of that really, and catastrophism, the two different schools of thought in geology. And then we're going to go back to Noah and the flood and see whether we can tie these ends together and look at rocks and fossils and try and work out from the fossils and the rocks what's going on and how you can possibly have a reconciliation between what you see in the rocks and what we read in our Bibles. And I'm going to finish off with what I'm going to propose as a kind of model for biblical geology. And just finally, a little thought about the significance of the flood for today. So what's it mean for today? What's it mean to us today? So let's get into Genesis. Genesis chapter 7. If you want to read about the flood, Genesis chapter 6 to 7, 8 covers the events of the flood. I'm just going to look at some of the things that Genesis chapter 7 mentions. And here we're reading what appears to be a historical account. Well, I believe it is a historical account of what happened in the days of Noah. And God spoke to Noah and said, "Go into the ark, you and all your household. Take with you 7 pairs of all clean animals, the male and his mate, and a pair of animals that are not clean, the male and his mate, and 7 pairs of birds of the heavens, also, male and female, to keep their offspring alive on the face of the earth." And then we read, "After 7 days the waters of the flood came upon the earth, in the 600th year of Noah's life." That's a rather interesting verse. We're not going to mention about the longevity of the people before the flood, but that's what it says in the Bible. And it gives you a date and a time, so fixing it in history. "On that day all the fountains of the great deep burst forth, and the windows of heaven were opened. And rain fell upon the earth 40 days and 40 nights. And then we carry on reading. "The flood continued 40 days on the earth. The waters increased and bore up the ark, and it rose high above the earth. The waters prevailed and increased greatly on the earth, and the ark floated on the face of the waters. And all flesh died that moved on the earth, birds, livestock, beasts, but all swarming creatures that swarm on the earth, and all mankind died in that flood, except those that were on the ark. Everything on dry land in whose nostrils was the breath of life died." That's quite a key verse, that one. Everything on dry land in whose nostrils the breath of life was the breath of life died. So in other words, anything that breathed air died in the flood, unless it was on the ark. And the waters prevailed on the earth 150 days. So that's what the Bible says. That's what we read in the Bible. Now, you might not believe it, you might believe some of it, you might think it's a embellished myth, but that's what the Bible says. So while we bear that in mind, we're going to now look at the history of geology. And we're going to think about some of the early geologists. We're going to start with a gentleman called Steno. He's Italian, I believe. He lived during the 1600s. And here's a picture of what he might have looked like. And he noticed that rocks were laid down in layers called strata. So he came up with the idea that the rocks were stratified, made up of horizontal layers of particles. And he also noticed that these layers of rock frequently contain remains of aquatic life, life living in the sea or living in rivers. So he concluded that these deposits were actually formed underwater. This was the beginning of geological science. And he actually came up with some early laws of geological science. First one being the law of superposition. Each stratum of such rocks was younger than the ones beneath it. So each layer, basically, the higher layers were young, the lower layers were old. Seems to make sense. If you've got layers of rock being laid down over time, you've got the older ones first and then the younger ones coming on top. That was his, and he also believed that all the stratified rock that he observed that were laid down in water would have been laid down by the flood described by Moses that we've read about in Genesis chapter 7. And then I'm going to talk a little bit about who are called some people who are called the scriptural geologists. Scriptural geologists are people who actually believe the Bible, but they're also geologists. And these geologists were actually catastrophists. In other words, they believed that various geological catastrophes occurred, which resulted in the laying down of these rock layers. One of these gentlemen was called Thomas Burnet. He was actually a cleric and a scientist. Very common in those days. Clerics didn't seem to have a very busy life, so they had time to pursue interesting scientific investigation as well. And another one is William Smith, who lived a bit later, the next generation. William Smith was an English geologist, and he was actually a canal builder by trade. And building canals, of course, he had to cut through sections of rock, so he discovered quite a lot about the layers of rock in the ground in Great Britain. So let's look at some of the work these two guys did. Thomas Burnet first. He wrote a book called The Sacred Theory of the Earth, except he wasn't called that because he wrote it in Latin. I won't attempt to repeat the Latin title, not being a linguist. And he wrote that in 1681. And he assumed the literal truth of the scriptural account, and he basically looked at the physics of the events of the flood and tried to understand how that would explain the layers of the rock that he was actually observing in the ground. And he assumed that the present features on the surface of the earth were actually created at the time of Noah's flood, and it was all down to Noah's flood. And his methodology was very much a scientific one, based on physical laws that he observed at the time. So he was actually a scientist who believed the Bible, but he also used a scientific method in his investigations. William Smith, a generation later, he actually produced the first coloured geological map of Great Britain. Here it is. A copy of his map, and he basically worked out a stratigraphic system of organised fossils. He didn't just look at the rocks, he looked at the fossils. He looked at the remains of the animals in the layers, and he was able to work out and classify the various rock layers on the basis of the fossils that he found. And so he was actually laying the foundations of modern geology using terminology that is still used today. And he also assigned relative ages to the different layers of rocks, basically saying which was the oldest, which was the youngest. And also by using the various fossils that he identified, he could pick up a bit of rock with a fossil in it and work out know the age because of the fossil. And that was his work in the 1800s. And he is basically considered the father of English stratigraphic geology and field paleontology, in other words, study of the fossils and the rocks. What we really arrive at this point in time, this is about 20 or 30 years before Charles Darwin wrote his famous Origin of Species, was they looked at the evidence and they concluded certain things. Basically, there had to be different ages for these sedimentary rocks. And they identified a whole series of characteristic fossils that you could use to identify the rocks. We're going to look at that a bit later in more detail. Well, not in much detail, but we're going to look at a bit of that. And they concluded, actually, something that might be quite surprising, that one single universal deluge was not a satisfactory explanation of the empirical evidence. They looked at the rocks, they looked at the fossils, they said, Noah's flood doesn't cut it. It's more complicated than that. 1 year of a flood doesn't work. And that was their conclusion. And these were people who actually believed the Bible, remember. And that's quite an interesting observation, which I want you to bear in mind as we go through the evening. I have to get the word paradigm into each of my talks, seeing I have a shop called Paradigm Shift, so I've got paradigm in here. There were two different paradigms actually at that time, which were sort of being used by the scientists of the day to explain the rocks and the fossils. The first one being catastrophism, which is basically characterized by rather violent events, a bit like a volcano but worse, versus what was called uniformitarianism, which was more tranquil and peaceable and taking a long time and going very slowly. So I now want to introduce you to the uniformitarians, And one of the earliest and well-known uniformitarians is James Hutton, who lived in 1726 to 1797, and he's considered the founder of modern geology. And he actually did a lot of his work around here. If you go into Arthur's Seat, Queen's Park, you can find Hutton's section. If you go to Sycamore Point, you will find these rocks here you see in the background. This is actually Sycamore Point, where Hutton did some observation. And he, this is what a statement from what he wrote, he wanted to look at the order of the rocks, considering it something which was in agreement with God's created order and God's wisdom. And it's not just, the rocks weren't just a random jumble of layers with no real explanation to them. So he was trying to put some order into it, but he was trying to do it in a context that was uniformitarian, and we're going to explain what that means in a little while. Here's a statement from another uniformitarian, a gentleman called Georges Fussel, I think he was French, about the same time. And this is one of the statements he made, which kind of sums up uniformitarianism and their theories. The manner in which nature at the present time is acting and producing things must be assumed as the rule of our explanation, meaning that you look around today, you see what's happening today, and you just extrapolate that, giving long periods of time, and you end up with what we observe in the ground, in the rocks and in the fossils. But it's all slow and gradual, no violence, no catastrophism. So it's completely the reverse of the catastrophist ideas. And this was Hutton's new theory, and it's been called Plutonist as opposed to Neptunist as well. Neptunist, the rocks come from the water. Pluton, the rocks come out of the ground in as very hot liquid form and then solidify. And Hutton's main effort, and people like Fussell as well, were very keen to emphasize the fact that the Earth must be very old, and it's slow, gradual processes that occur which explain what we see today. The physical processes of the present and the past are the same kind and proceed in the same way. So what we see today, what we see happening today, is what would have happened 10 million years ago, 100 million years ago, a billion years ago, if you want to go that way. And they'll be the same intensity. So you haven't got something markedly different from what we see today. And the other third part will be they occur at the same rate. That's really the principles of uniformitarianism. And Hutton was one of the fathers, if you like, of uniformitarianism. And he looked at the layers of sedimentary rock he found around Edinburgh. He looked at the rocks at Sycamore Point and other places. And he assumed that long periods of time, slow, gradual processes would account for what he observed. Now, that's the catchphrase really of the uniformitarians is the present is the key to the past. You look at what's happening now, and you see how you can explain the past. If you go to the dynamic Earth, you will see this plastered on the walls. It used to be anyway, but last time I was at dynamic Earth, they put this up on the walls so everyone realised the present is the key to the past. But not everyone was happy with this situation, and there was actually a catastrophist counterattack launched by various people, one of whom was Georges Cuvier, another Frenchman, living a little bit later than Hutton. And he studied the layers around the Paris Basin. This is where he lived. And he proposed a series of sudden inundations and retreats of the sea. On the basis of what he observed, the empirical evidence led him to conclude that there was a whole series of sudden, rapid movements where the sea came in and then washed away again. And he looked at the rock layers. Here's a picture of one of his diagrams that he drew himself of all the various rock layers. And he concluded that these pieces were being broken up and showing that there was a whole series of what he termed revolutions that were sudden and violent, just like the last, which he would have concluded was the flood. So he was kind of reacting to the uniformitarians and saying, actually, what we see today doesn't explain what we observe in the rocks. Processes are too slow and too small. And even volcanic action, which is quite violent, is localized. It's just too local. It's not going to explain all the effects that we see. And he concluded rather that the evidence shows a series of major catastrophes. And very interestingly, Cuvier went around and collected accounts of the Great Flood, which exists in various different cultures. There's a whole load of cultures that have stories about a flood, all variations on a theme very similar to what Noah's flood was like if you read the Bible account. So Cuvier was reacting to the uniformitarians and saying, no, that doesn't work. What I observe in the field actually supports catastrophism. And then you have Charles Lyell, who really won the day, and he wrote in 1830 the Principles of Geology. And what was he doing? He strongly reasserted the principles of strict uniformitarianism. And he had an objective in mind. He had an agenda, and his agenda was very clear. He wrote about it, not in his books, but in his personal letters to his family, and said that his objective was actually to free geology from Moses. He wanted to get away from the fact that the Bible was directing where geology went. He said, I'm not going to have the Bible telling me how to do my geology. And I want to get rid of the Bible. I want to get rid of Moses because he writes about the flood, and I don't like the flood because the flood doesn't fit my ideas. Not necessarily that the evidence was supporting that, but that's what he was proposing. So he very strongly reasserted uniformitarian principles. And he claimed that given sufficient time, present-day forces operating at present rates could have produced all the geological phenomenon. But he actually needs a great long period of time, millions and millions of years, for that to work. And Lyell really is Lyell's principles are ruling principles of geology today. People generally hold to Lyell that given sufficient time, present-day forces at present-day rates produces all the geology we observe around us. Okay, so that was geology. Now we're going to go back to Noah and the flood and think about what was Noah's flood like. What can we discern happened during the flood from the account in the Bible, and what kind of things can we conclude about the flood? The first thing we need to deal with is, was Noah's flood local or not? And that's a question that people ask. Some people who claim to believe the Bible say, well, there was a flood, but it was local, it was a small thing, and you can't really just work out where it happened in the rocks. It was some local event that upset a few people, but not very many people. Well, if it was a local flood, you have to ask yourself the following questions. Why build a huge boat? And it was a huge boat, we'll come to that in a minute. If it's a local flood, you can just walk away, especially if you're warned in enough time. And the Bible account, the verses of the Bible I showed you earlier, clearly demand that the whole earth was covered with water. There's just no two ways about it. And why did God promise later on in the next chapters of the Bible never to flood the earth again? If it's only a local flood, because local floods still take place. So my conclusion is that the Bible clearly says it was a worldwide flood. Let's think about the flood a bit more. First thing I'd like to point out is the onset of the flood was very violent. It was very catastrophic. Talked about the fountains of the great deep breaking up, the windows of heaven opening, and talks about all air-breathing life being destroyed. And there would possibly have been massive volcanism. I interpret the fountains of the great deep breaking up, meaning the actual crust of the earth was breaking up, and that would lead to great volcanism, massive volcanic activity. You'd get lots of superheated water. You had torrential rain. It rained for 40 days and 40 nights. And the implication is that was not just a little shower, it was torrential rain. And we've got total destruction of the land surface. And in fact, outside of the ark, the only thing that survives is life in the sea. Everything else is obliterated unless it's in the ark. All air-breathing animals were destroyed by the flood. And in fact, I would suggest that the whole surface of the earth was destroyed by the flood. It was completely obliterated. Right, let's think about Noah's Ark. Okay, Noah was told to build an ark, and he was supposed to take all the animals into the ark. How big was the ark? Well, here are some diagrams illustrating the size of the ark. It had 3 decks, we're told. Here's a picture of what it might look like. A large box. It's actually a very ideal shape. The dimensions, the proportions are ideal if you want a barge to float quite stably on water. And we have an idea here that the whole ark would have been about 437 feet long, 45 feet high, and 37 feet wide. You have a jumbo jet here for comparison, some large dinosaurs, and a few modern-day animals, an elephant and giraffe, just showing you the scale of the ark, courtesy of Answers in Genesis. But these will be minimum dimensions, because we're not told in feet and inches or meters. We're told that the ark was so many cubits. And it depends how long a cubit is, which depends how big your arm is. So we don't really know. But this would have been a minimum size for the ark. And it would have had about 9,240 square metres. And just to give you an idea, a large house, not your average three-bed semi, but a large house would be 150 square metres surface area. So you've got quite a lot of space on the ark. So it was a large floating box, if you like. But how did all the animals fit? Well, first of all, we have to think about the type of animals that would have been there. How many animals? Well, actually, if you're thinking kinds of animal, it's okay, Phil, I've got a cup. Thank you. If you're thinking kinds of animal, we're not talking about species here. We're talking about sort of groups like, take the cats, take the dogs, take horses as a kind, but including things like zebras. You actually, if you work it out, you come up with several thousand kinds of animal, and the average size of which is about the size of a sheep or a goat. And I would suggest that the dinosaurs might well have been smaller before the flood. Now, I've got no evidence for that, but there is some evidence to support that view. But at the very least, you didn't have to take full-grown adult dinosaurs on the ark. And in fact, part of my understanding of the flood and the aftermath of the flood is that new species actually appeared after the flood. So you would have had kinds of animal on the ark, like the dog kind, like the cat kind, but the cat kind will include your domestic cat, your lions and tigers, and these would actually appeared after the flood. So if you take all these things into account, it's actually very feasible that Noah could have got all the animals on the ark. And if you want to read more about that, there's other people who have written quite detailed technical accounts of what the ark would have been like, what it could have been like, how it could have all worked. And you can read up about that. I just wanted to think a bit more about dinosaurs, because dinosaurs, of course, grab everyone's interest. Pre-flood dinosaurs, I would suggest, were small, and we know they were vegetarian before the flood, because we're told in the Bible that dinosaurs were vegetarian and didn't become carnivorous, and carnivory did not occur until after the flood. So I would suggest they were small and definitely vegetarian before the flood. But post-flood dinosaurs, to give it a technical term, would have been hypermorphic. They underwent delayed reproduction and extended growth phase, which explains why they got very large after the flood. And I might not be entirely clear. I haven't got time to go into why they got very large after the flood, but if you have questions about that, you can ask me afterwards. And some of them would have become carnivorous after the flood. So there's been a change in what the dinosaurs were like before and after the flood. And in fact, the giant dinosaurs were only present on the Earth during the Cretaceous period, not the Jurassic as in Jurassic Park. It's actually wrong. It should be Cretaceous Park, but it doesn't sound quite so good, obviously. I don't know who advised them, but anyway, it wasn't the Jurassic, it was the Cretaceous. So now you know. So that's a quick overview of the events of the flood and some events after the flood. Just a quick look at dinosaurs. But I want to sort of expand it out and go back now to geology, trying to put it all together. I know I'm jumping around a lot. There's a lot of ground to cover, but hopefully at question time you can fill in the gaps with your questions. Here we have the classic geological column of mainly sedimentary rocks and Precambrian here, but the Precambrian actually goes way down here, if you're doing it relatively speaking. These are all the sedimentary rocks: Cambrian, Ordovician, Devonian, Mississippian, Pennsylvanian, Permian, Triassic, Jurassic, Lower Cretaceous, Upper Cretaceous, Tertiary. And we're sitting on top here. And this is the classic geological column. Underneath all the sedimentary rocks, you've got the igneous rocks, which are the Precambrian, as well as some Precambrian sedimentary rocks as well, but they're mainly igneous and metamorphic. And then you've got the sedimentary rocks, which are all these here, Cambrian upwards, and it's the sedimentary rocks that are made up of small particles carried around by water, wind, or volcanism. And you've got metamorphic rocks as well, just to complete the picture. Metamorphic rocks are actually sedimentary rocks that have been heated and deformed and compressed and turned into a different form of rock, but originally were sedimentary. And the fossils are actually found here, from the Cambrian upwards. This is where you find your fossils. So sedimentary rocks have got fossils in them, igneous rocks don't have fossils in them, and metamorphic rocks generally don't have fossils in them. Even if they did originally when they were sedimentary, the heat and the pressure would have destroyed any fossil remains. So that's the geological column. Let's think about fossils, because the way fossils form is actually very important when you're thinking about the flood and how it fits in with geology and how we can understand geology from a biblical perspective. First thing is fossilisation is a very rare event. It's not every day, it doesn't happen all the time. And this is actually where uniformitarianism falls down, because you can't see fossilisation occurring today on the scale that it must have done to account for all the fossils you find in the rocks. And the commonest fossils are marine animals, arthropods, mollusks and fish, or arthropod-like animals. And that accounts for about 99% of all known fossils, are basically what lived in water. And you tend to get more of the second most important amount of fossils will be the animals living in coastal and river floodplains, like dinosaurs, actually. Dinosaurs almost certainly lived in floodplains. If you think of the US is full of dinosaur graveyards, and a lot of the US at one time was a floodplain, which is why you get the fossilization of the dinosaurs there. And mammals and birds are very, very rare. You don't find many mammal and bird fossils for sale in fossil shops. And if you do, they are incredibly expensive because they are incredibly rare. In fact, dinosaurs are incredibly rare as well, whole dinosaurs. Bits of dinosaur are quite common, but there's only about 6 Tyrannosaurus rex fossils, for example, complete Tyrannosaurus rex fossils. But the large animals are more likely to be fossilised. Right, that's a quick overview of some things about fossils. And I just want to sort of try and highlight some of the things that, when I say we, I mean we might. I mean, I'm basically speaking for myself here, because a lot of what I'm saying this evening actually wouldn't agree with a lot of creationists. So I'm not agreeing with non-creationist geologists, I'm not agreeing with creationist geologists either. I'm making my life difficult. I'm not alone, I would hasten to add. There are some who have similar views to me. But we agree, or I agree, that the geological column actually exists. That diagram I put up on the screen earlier, that more or less reflects reality. If you go out in the field, you can see all the rocks. In fact, if you travel from north-west Scotland down to southeast England, you're walking over most of the layers of rock, starting at the Cambrian and ending up with the Cretaceous and the Tertiary down the south. So it does actually appear to exist. It's idealised and stylised in the diagrams, but the empirical evidence is there to support there is some sort of geological column, which is exactly what the earliest geologists found, who were actual Bible-believing Christians. And so there is a sequence with the oldest rocks at the bottom and the youngest at the top. I have no problem with that. Old ones at the bottom, younger at the top. It's the ages that I might have a problem with. And I also agree that there is evidence for at least 5 mass extinctions in the geological record. You can go through a geological record. If you read your geology books and your books about fossils, they will talk about the various mass extinctions, the most famous one, of course, being the one that wiped out all the dinosaurs, which is the last one. But then there are certain things I do not agree, and it's very important, and I think most creationists would agree with me on these ones. The extinct animals were not primitive. They're not fossils, they're not extinct because they were primitive. They're fossils and they're extinct because they're in the wrong place at the wrong time. And the sequence of the fossils, particularly, was not caused by evolution. And just to go back on the idea of primitive or not primitive, if you look at some of the fossils, well-known fossils, trilobites, for example, which are the earliest fossils, Cambrian fossils going up to a few hundred million years, according to the geological time scale. Trilobites were not primitive. They were advanced creatures, very complex. They had eyes, very complex eyes. The therapsids, one of my favourites actually. I'm going to do some research on therapsids. Maybe next year we'll have a talk on the mammal-like reptiles, because it's something that fascinates me. These were not primitive animals, and these lived during the Permian era. They were not primitive. There's even some evidence to suggest that they were hot-blooded like mammals, which is why they're called mammal-like reptiles. I would dispute the reptiles bit. Birds. Birds are actually quite old in geological terms if you stick to the classical geological timescale, which I don't, of course. But birds first appear in Jurassic, which is quite old. And they are clearly very advanced creatures. Dinosaurs themselves actually are very advanced, very sophisticated animals. So the idea that animals are extinct because they were primitive is not true. They were in the wrong place at the wrong time. Okay, let's just think about some of the fossil layers. I'll just take a very rapid overview of what some of the things that we observe. Start with the Precambrian. This is Torridon, which I believe is Precambrian rock. I've been walking along here, it's quite fun. There's the 3 horns of Ben Allegan. and I believe that is Precambrian rock. And there are very few fossils. I didn't see any, but very rarely do anyway. And it's igneous and metamorphic mainly, but some sedimentary Precambrian rock as well. But there is evidence of massive erosion. And I would suggest to you that the Precambrian, the end of the Precambrian, the beginning of the Cambrian, is actually the destructive start to the flood. There's the record in the geological column of when the flood started. Then we move into the Cambrian. The Cambrian actually is a massive challenge to evolution. And it's not very often mentioned when you introduce evolution. I mean, today we're told that we must teach our children evolution. Well, they don't usually teach them about the Cambrian explosion, because the Cambrian explosion is a bit of an embarrassment to a Darwinist. Because basically you've got lots of very complicated advanced life forms. And you get almost all the phyla, almost all the various types of animals are represented in the Cambrian rock layers. There's a few missing, but most of them are there. And here we have some very interesting looking creatures reconstructed from the fossils in the Cambrian. And there's very abrupt appearance. There's no ancestors to the trilobites. Or they try to suggest there are some, but I would suggest that their attempts are not very convincing. And we have complex morphology. So a massive challenge to evolution already in the first layers of rock which have fossils in them. All of a sudden, you have an awful lot of complex life forms and represent just about every phyla that we know today. And how does that fit in the flood? Well, this, I would suggest to you, is the recolonisation of the shallow seas towards the end of the flood. And why did they get fossilised? Because a whole load of sediment came off the land surface as the water were draining off the earth and covered them with sediment. So they happened to be in the wrong place at the wrong time. And here's another picture of the various life forms that were present in the Cambrian. Here you've got trilobites and other creatures similar. This one here is interesting because it's a chordate. It's actually got a vertebral column. Existed 500 million years ago. Didn't evolve over long periods of time. Ordovician. What did the Ordovician life look like? I want you to notice that a lot of this we see here, we don't see any land creatures. Ordovician, push the right button. Here we have a picture of the Ordovician seas with various creatures. Here you've got a squid-like animal and other squid-like animals, and the odd trilobite still here, and sponges and similar things. Let's keep moving rapidly. Silurian. Silurian, you've got trilobites, and you've got this chap, which is actually a picture of a live nautilus. Well, they were alive in the Silurian, which was 400 million years ago, so we're told by evolutionists, and they haven't evolved since, which is an interesting question, but we won't go there tonight. Devonian, the classic Devonian fossil is a Devonian fish, rather strange-looking fish, which are now extinct, but again, I would argue they're not primitive, they just happen to be in the wrong place at the wrong time. And up until now, we have nothing that walks around on land. So here we have, I would suggest to you, the recovery of life in the seas shortly after the flood. Mainly in the shallow seas near the land masses, because that's why they got fossilised. Because all this time, the land was recovering, the earth was recovering, there were various different geological catastrophes taking place, which were causing an awful lot of sedimentation. And when you have a lot of sedimentation, you tend to get lots of rock dumped on you, you become a fossil. And the late Devonian, early Carboniferous, you've actually got some creatures which are starting to have legs. There's a lot of debate about whether this thing lived in the water. I think the consensus now is it lived in the water. It's an early, so-called early amphibian, early reptile. And then when you get into the Permian, you get animals with legs walking around on land. So for me, the Permian is the land animals which came off the ark. They had to come off the ark because, remember, that during the flood, all air-breathing life was destroyed. And the onset of the flood was the first 40 days. And the only way you're going to get animals walking around on the land after that is they had to come off the ark. So these were descendants of animals that came off the ark in the Permian era. Let's think some more about fossils, because this is very important in understanding this. Fossils, as I already said, do not show evolution. They show abrupt appearance and stasis. We've seen that with the Cambrian explosion. But this is what I want to focus your attention on just now. The evolutionist assumes a lot of it is missing. They admit that they haven't got all the fossils they need to prove evolution. They've got some, but they generally, everyone would agree, you've got abrupt appearance and stasis. The evolutionary transitions happen so quickly, they say, that they weren't fossilised. So the evolutionist assumes a lot of it is missing. But the creationist, I would suggest, should assume that it's actually fairly complete. So in the fossils, we have representative of just about every type of animal that ever lived. And some of them are still alive today. And that kind of changes your perspective when you think about geology and evolution. Why assume it's missing? You assume it's missing because you believe in evolution and you have to explain why you haven't got all the transitional forms you need. If you're a creationist, you don't believe in evolution, you don't have to explain away the missing fossils, they just weren't missing. Which is the simplest solution, which is where if you apply Occam's razor, I would suggest to you the creationist position is actually simpler. How do fossils form? Before you get fossils formed, you have to have established groups of animals. You've got to have a lot of animals around to get a fossil formed because a fossilization is a rare event. So you need lots of animals to increase your chances of being fossilized. If you're just the one representative of your species wandering around, you're very unlikely to get fossilized, whereas if there's hundreds of millions of you, you're much more likely to get fossilized. So you need lots of animals, and that's quite important. It also requires rapid deposition of sediment, which goes against uniformitarianism, because uniformitarianists say it's slow and gradual, and we're going to come back to that in a minute and think about some of the numbers. And it does require often episodic deposition of sediment, because you get different fossil collections in different layers of rock as you go up, and it appears that there's been a period of time when life has been fairly tranquil and life grows nicely on the ocean bed. A load of sediment comes in, dumped on top, turns them into fossils, and then something else starts living on top, and then another load of sediment comes in and is dumped on top. But that takes time, and it can't all be explained in 1 year of the flood. It's just not biologically possible. So fossils actually are evidence of catastrophic geological processes. So let's put up some hypotheses here. Now, creationists are often accused of not doing proper science because they can't put forward hypotheses that can be tested. Well, I'm going to try and prove that that's not the case here by putting up some hypotheses that can be tested. This is a working hypothesis for you. Different fossil-bearing strata represent the flood and different stages of post-flood recovery interrupted by catastrophic events. So the idea is you have the flood, massive catastrophe, all life on land destroyed, perhaps quite a lot of land in the sea, and then you get a recovery after the flood, or towards the end of the flood, after the flood. And what we're seeing is actually the recovery, but also interrupted by various catastrophic events because the Earth took a while to recover from the flood. In fact, we still haven't recovered from the flood. We're still living in the aftermath of the flood. Okay, we can make some predictions from this hypothesis. We can say, okay, let's think about the fossil abundance if we're going to adopt this hypothesis. Because we're looking at a flood situation, marine plants and animals will be most common because they will recover first and they will grow quite fast, they breed quite fast, and they would be in an ideal situation to be fossilized because they live in water and sediment is carried by water. So that's a prediction we could make from that model. And animals living in coastal areas will actually be more common in the fossil record. And this would be a slightly later stage in the recovery of the Earth after the flood. And inland terrestrial animals will be very rare because they wouldn't be in places where you could get easily fossilized. And also, they're going to be taking longer to recover because they come off the ark and have to start breeding. Before you get appreciable numbers of animals, you're going to have a period of time to elapse. And the catastrophes are getting less and less severe as time goes on. And the general prediction you'd make here, the fastest breeding land animals would appear first in your fossil record. And let's think about fossil land animals because this is key in actually understanding the flood and where the flood fits in the geological record. And this is key in where I would disagree with quite a lot of creationists. So I'm setting myself up to be shot down from both sides here. Fossil land animals give a record of recolonisation of the Earth after the flood. So basically the fossils weren't formed in the flood, most of them. Well, that's not entirely true because most of the fossils are marine and some of the marine ones were formed in the flood. But the land animals we're talking about here, the land animals, not the marine animals, are a record of, the fossil land animals are a record of recolonisation after flood. Rapid breeders appear first, such as amphibians and reptiles, which lay eggs. If you lay eggs, you tend to breed very fast because you have massive generations. So you lay 100 eggs, you get 100 little frogs. We only produce one offspring at a time between two of us. Small mammals and birds will also be quite rapid breeders, so they would appear in the fossil record. Small mammals especially would appear before the large mammals, and birds would appear before large mammals. And large dinosaurs will come later because the large dinosaur is growing more slowly, especially if you remember they've delayed reproduction and increasing in size, so they're not breeding quite so fast after the flood. And your large land mammals will be even slower because they take the longest to breed. If you're an elephant, you have a gestation period of 2 years. So your population is going to grow very slowly. So that's the kind of the way we would expect the record to develop as we look through the fossil layers, the rock layers. So how does that actually match up with our geological record here? Well, we have amphibians and reptiles here, land mammals. Now remember here, I showed you earlier, Cambrian up to Devonian, mainly fish and aquatic animals swimming around in the water. Here the land animals appear in the Carboniferous, in the late Devonian, early Carboniferous. And we have amphibians and reptiles, small ones. Then we have these mammal-like reptiles appear here, and I haven't quite worked out these ones yet, but I would assume, according to my hypothesis, they must have been quite fast breeders, because they appear in the Permian. And then you have small mammals and birds actually start appearing in the Jurassic. Then you have your large dinosaurs, which are Cretaceous, remember, not Jurassic. And large mammals come later in the Tertiary. And that actually fits my model. I might say I've cheated a bit, maybe I have. But this is a model that can be developed, it can be examined, it can be tested empirically. And that is what you find in the rocks. And that fits the story of recolonisation of the Earth after the flood. And the key thing is, any rock with footprints in it, footprints of animals walking around on 4 legs or 2 legs, according to my hypothesis, have to be post-flood deposits. Because remember, in the flood, every creature on land was killed off, obliterated. They didn't have time to wander around making footprints. They certainly didn't have time to wander around laying eggs, which is what the dinosaurs did. Right, up here in the Cretaceous and Jurassic. So if you find footprints in the rocks, I would suggest to you that that is post-flood rock. Okay, where are we going? Right, back to geology again, a bit more geology, so classical geology now, not creationist geology. I want to mention a gentleman called Ager, who, if he was alive, he'd be fuming and frothing at the mouth, because he expressly said that what he taught mustn't be mentioned by creationists and used by creationists. Well, I'm sorry. What he said is actually very useful to the creationists, because he is a catastrophist, and he complained quite a lot about Lyell, who had actually hijacked the whole of geology and made it uniformitarian when it doesn't actually fit the evidence. So we're actually going full circle, but Ager's theories aren't accepted by the mainstream as yet, although I think you'll find that his ideas are becoming more and more acceptable. But he said this: for a century and a half, the geological world has been dominated, even brainwashed, by gradualist uniformitarianism of Charles Lyell. Now that's a pretty big statement, but this is a geologist. This is not a creationist, he's an atheist, or he was, he's now dead, so he's no longer an atheist. But he said the whole of geology has been brainwashed by Charles Lyell. No, so much for objective science based on the empirical evidence. And any suggestion of catastrophic events has been rejected as old-fashioned, unscientific, and even laughable. Then he goes on to moan about the creationists, of course, who are catastrophists. And he says, by the way, anything I say mustn't be used by creationists. Well, I'm sorry. I've done it. But let's test catastrophism. Let's have a think about what Ager was saying. I've got time to go into detail. But we need to think, is what we observed the result of slow gradual deposition or rapid deposition? And I've gone on the internet and looked up some information. And there's a place called Morton County in Kansas. And here's a picture of it, from rock outcrops. And you've basically got rocks from what's called the Mesozoic era, which is the Triassic, Jurassic and Cretaceous together. Period that spans about 180 million years. And the layers of rock are about 1,000 metres thick. So you can actually go there and look, and you can measure it up. You've got about 1,000 metres. And as I said, this covers a time span of 180 million years. Okay, so let's do the maths. If you heard John Mackay earlier this week, he'd done the same thing. I stole this from him. Well, not exact example, but he did mention it. Do the maths. 1 millimetre in 180 years. That's how fast the rock is being deposited. Well, big deal. But yes, it is a big deal, because what's in the Triassic, Jurassic and Cretaceous rock? Loads of fossils, right? Including, in the Cretaceous, massive great dinosaurs. So you have a dinosaur dies, and the rock is being deposited around it 1 millimetre in 180 years. And it turns into a fossil? I don't think so. So you have to have rapid deposition for it to work. There's no way you're going to get a fossil formed with rock being laid down 1 millimetre in 180 years. Now, perhaps the rock layer is a bit thin here because it's been eroded away. So you could be generous and say, okay, 1 millimetre in 18 years, if your layer is actually 10 times the thickness originally. But you're still not going to get fossilisation at that rate. And let's think about what's not happening today, which is observable in the rocks. You've got massive erosion. I mean, continent-wide erosion, not just a little bit of erosion in a river. You've got thick layers of mud and sand, and when I say thick layers, kilometres thick. You've got continent-wide layers, layers of rock which just cover whole continents. That's not happening today. It just doesn't work. You've got sea animals far above sea level. So you've got fish on the Alps. That doesn't happen today. You've got sand being carried across continents. Mainly, the main evidence for this is the US. Got sand started off in the Appalachians, arriving in the Sierra Nevada or equivalent in the Grand Canyon. So these things did not actually occur today, but they are observable in the rocks. So I would suggest that Mr. Ager is correct, and lots of geologists are starting to think that maybe his ideas have to be incorporated in modern geology, and uniformitarianism has had its day. But of course, if we're talking about the flood, we're talking about the fossils, we have to think about the age of the Earth, because if you read your Bible, you will quite rightly say, but hang on a minute, the flood took place 4,000 years ago. But what about radiometric dating? So we have to think about radiometric dating very quickly. How am I doing for time? Very quickly, as I said. There are many assumptions in radiometric dating. You can't do it directly. If you're doing an analytical method, and I did spend a bit of time working in a laboratory doing analytical methods, you have to have a standard. You have to have samples of known concentration or known age. So you have to take a rock that you know is 10 million years old, date it, and prove your method works. Well, of course, you can't do that with rocks, because you don't know externally that a rock is 10 million years old. You just make the assumption. That's just one of the assumptions you make when you do make radiometric dating. The very nature of radiometric dating gives you a minimum age for each dating method. You don't get zero age, you actually get an age which is indistinguishable from an age which will be a proportion of the half-life of the isotope you're measuring. Now, one of the isotopes that's used has a half-life of 1.62 billion years. Right, that's one of the quicker ones when you're using for dating rocks. And some of the other ones have half-lives that go into 40, 50, 60 billion years, 100 billion years. So if you get some decay, your minimum age is going to be millions of years by default, because it's the minimum you can detect. So you're never going to get ages, except with some of the methods you can, but most of the methods, you get ages automatically. They're going to be tens of millions of years, because that's a minimum you can detect. It's non-distinguishable from zero. So that already biases you to old ages. And furthermore, radiometric dates can only be used for igneous and volcanic rocks. You can't radiometrically date sedimentary rocks with a fossil in it. It's impossible. So sedimentary rocks cannot be dated. You have to do it by inference. So much for absolute dating methods. And just very quickly, I want to point you to some anomalous radiometric dates coming from the Grand Canyon. Two layers of rock in the Grand Canyon. One is the Cardenas basalt, which is Precambrian. Another one is a lava flow, which is considered to be modern because it's on top. Makes sense. So far, so good. Precambrian strata of the Cardenas basalt, lowest and the oldest strata of the Grand Canyon, suggested age of more than 1 billion years. Right, let's look at the radiometric dates that they actually are published. Different methods. You've got rubidium-strontium method, gives you 1.2 billion. The samarium neodymium, I think it's neodymium, SMND, 1.6 billion years. Lead gives you 1.8, and potassium argon gives you 1.2 billion years. Oh, well, so what? We've got billions of years. Yeah, okay. Let's just actually look at it. I've plotted them on a graph here. Here we have the rubidium-strontium, the samarium, the lead, and the potassium argon. Here's the value, and here we have plus or minus 2 standard deviations. Now, if you're a statistician and you know any statistics, you know that if plus or minus 2 standard deviations gives you the majority of the data, and if it's non-overlapping, it's statistically significantly different. So these ages are actually, you've got 3 different ages here, which are statistically significantly different. These are the same. They overlap. They're right inside each other. These two are different. This is supposed to be an absolute dating method, using different radioisotopes. Why do they give you different answers? Well, when I have an answer to that question, I might start believing radiometric dating. So that's just one little problem about radiometric dating. We could go on about lots of things like radiocarbon. We can go on about helium in zircons. There's lots and lots of questions you can ask about radiometric dating. And very quickly, I'll just skip through this. The lava dam, there's what they call the lava dam. Here's a picture of it. Lava's just flowed off the top and down the side of the Grand Canyon. And you can age this using potassium argon. And it comes out with a potassium argon age of 1.2 million years. Great, that fits exactly what we expected. But hang on a minute, you do rubidium and strontium, you get one age that's 10 times greater, which is right. Well, I would suggest you both are wrong. So radiometric dating, for me, is just not convincing. It's not accurate, it's not precise. It's so many assumptions, so many adjustments made that you really have to believe it to want to believe it. See what I mean? Okay, by way of summary then, trying to pull all these threads together, and I know I've left lots of things unsaid, and hopefully there'll be time for questions. Geology is catastrophic, and even atheist geologists are agreeing that. Even old Earth geologists are agreeing that it has to be catastrophic. It cannot be all explained by slow, gradual processes. And I would suggest your radiometric dating methods are unreliable. They cannot be confirmed independently, and I'm not going to ditch my faith on the basis of some very dubious methods. And this is really controversial. Fossil records is actually a record of population explosions and mass extinctions. The recovery of the flood, remember, especially when you're talking about land fossils. So, put it all together into what I would call biblical geology. You have a geology that's young Earth. So basically the Earth is young, catastrophic, and all parts of the Earth are covered by sedimentary rocks. Therefore, all parts of the Earth were once underwater, which is entirely consistent with a flood. And the fossils are a key to understanding the sequence. And fossils, as we've already seen, well, we haven't really explained it in detail, but fossils do require rapid deposition because your animal's not going to lie there for hundreds of years while it gets covered in rock. It's going to rot away or get eaten or dragged away. Something else will happen to it. You have to have catastrophic events to get fossils formed. And just some more points, looking at how it fits in the geological record. The Precambrian is the start of the flood. Very massive destructive forces being unleashed, destroying the land surface, and that's what you find in the Precambrian rocks mainly. Cambrian is the end of the flood, where you've got marine fossils actually coming back into the continental shelves and starting to re-establish ecological niches in the continental shelves. Then you've got the Ordovician to Devonian, it's your early post-flood, when you've got your fishes moving in, and as various sediments get washed off the earth due to various other catastrophes that occurred during the geological record. Remember the 5 extinction events. You get them covered with rocks and turned into fossils. And the Carboniferous onwards, you start finding footprints in the rock. So these are animals from the ark. They've come off the ark, they've produced their offspring, they've started to breed, start to establish large numbers, and here you have them recorded as fossils. And the post-flood extinctions basically coincide with less global catastrophes associated with things like rapid mountain building and rapid continental drift. So very, very rapidly there, we've had loads of things thrown at you, but there will be time for questions. I just want to conclude now, though, going back to what the Bible says, because the flood has actually significance for today, not just in terms of geology. It has massive implications for geology, but it also has massive implications for us as individuals. Because the Bible says in 2 Peter, some will say, where is the promise of his coming? Saying, because Christians believe Jesus is coming again one day. But the skeptics say, ever since the fathers fell asleep, all things are continuing as they are from the beginning of creation. Sounds just like uniformitarianism. But they deliberately overlook the fact that the heavens existed long ago, and the earth was formed out of water and through water by the word of God, that by means of these, the world that then existed was deluged with water and perished. There was a flood. The world was obliterated by a flood, and that's history. But by the word of God, the heavens and the earth that now exist are stored up for fire, being kept until the day of judgment and destruction of the ungodly. There will be one final catastrophe when this whole earth comes to an end at the return of Jesus Christ. And we're told that will be a catastrophe by fire, not by flood. So what does that mean? There is a final catastrophe coming, and the world will be destroyed by fire, the Bible tells us. And we need to pay heed to the example of Noah. Noah listened to God. When God told him to build an ark and go into that ark, he went in and he was saved. Many other people could have gone into the ark with him, and they refused to go. They did not believe. Well, we have one place of safety today, and that is Jesus Christ, who is the only Saviour. If we want to escape from the final catastrophe, we have to put our faith in Jesus Christ. That is the significance of the flood from a spiritual point of view. And there I will finish my talk and open up for questions.